Lesson 2 in statistics, we're going to be taking a look at standard deviation. You'll see on top there the title, it's all about standard deviation, and we're going to go through what that is and how we can solve for it. And we're going to be doing that today. In the previous lesson that we went through, we took a look at mean, median, and mode, and how those are three of the measures of central tendency. They kind of measure what is the middle. Okay? Where do we kind of stand? What is middle? What is, and again, I use this term loosely, but what is normal? Okay, and normal is often represented by what is kind of in that middle. And where are most of the data points at? That's what we consider to be normal. Whether that's mean, median, or mode, those are all normal. Standard deviation is a measure of how, or it can be measured on how spread out things are, and it is based on our mean as well. So it's based on our normal or based on our average. So we're going to take a look today at a little bit of an example, and we're going to get into this example a little bit later as well. But first off, let's just go through the example. So Mr. Barkman had two classes of grade 11 students and gave the same test in each class. The mean grade on each test for each class was given. Now let's compare the results of the two classes. You'll see class A over here. On the first test, they got 67%, second test, 76, third test, 69, 68, and 67, and so on and so forth. Okay, so these are the first, this is the first group here. The second class had these 5 scores as their averages for the test. Now, if you take a look at those numbers, there's a couple things that you can interpolate or understand right off the bat. First off, if you look at that, class A probably did a lot better. And let's use our measures of central tendency to take a look at that. So we're going to take a look at mean, median, and mode of for class A. We can fit this all in here. It would take, but I think we'll get it in here. All right, so the mean is all the numbers added up, and then we divide by the numbers. So I'm going to use my calculator. I'm going to do 67 plus 76 plus 69 plus 68 plus 67, and that equals to 347 right there in the little corner there. Okay, divide that by 5, and we get a mean of 69.4%. Okay. The median in this case here is if we put them all in order and then find the middle one. Okay, 67, there's 2 of those, and 68, 69, and 76. So the middle one is going to be 68%. And the mode is the most common one, so it's the one that happens most often. We have, it is 67%, there's 2 of them. Now you'll notice here that all those numbers are very close to each other. Okay, so they're all pretty close. They're all roughly in the same area. Okay, 69, 68, 67. That's pretty. They're pretty similar altogether. Let's take a look at class B. The mean. Again, we add them all together and divide by 5. So we get 56 plus 61 plus 56 plus 54 plus 40. And we divide that all by 5, and so we get a mean of 53.4%. We have a median. So again, 40 is the lowest, and then we have 54, and then 2 at 56, and then 1 at 61. The median is going to be 56%, and the mode is also 56%, as there are 2 of them. So again, we're solving for our measure of central tendency. Now, when we look at these two here, you can definitely say the mean better in class A, median better in class A, mode better in class A. Okay, so class A probably did better on their tests than class B. Okay, all sorts of different reasons for that, but in this case here, that was just the way that it was. Okay. Now, when we talk about standard deviation is how consistent or how spread out the data is around the mean. Okay. So how close to the normal do we have? Okay, how close to normal we have? If you take a look at class A, yeah, they have that 176% there, but everything else is like 67 to 69. That's pretty close. In class B, you'll notice that there's that 40 that's kind of an abnormality, so to speak, but then the rest of them are, well, we have 3 of them that are in the 50s, but then we have one in the 60s, a little bit more spread out. If we were to plot this on a graph, we would have a little bit more spread out data, not so tight and combined. An example that I use for this is if we were to take a look at average ages of certain people, okay? So certain groups of people. The first group that we'll take a look at is, let's say, our class. The average age in our class is, well, you know what, probably 16, 17 years old, right? Everybody is roughly in that 16 years old range, okay, depending on what time of the year it is in grade 11. Roughly 16 years old would be the average, maybe 16 to 17 years old. So that's the average. And majority of you in class are going to be very, very, very close to that average because everybody is from a very small grouping and you're put into this class here. If we were to now take the average of the school, okay, so the average of the school, well, now we have ages from 14 to 18 and maybe even some more. There's some students here that are a little bit older, okay? So we have a wider range and the average might still be pretty close. It might be about 15 to 16, but now we're going to be farther, some people are farther away from that average. Move into the city of Steinbach, and if we looked at the average age of the people in Steinbach, there's a really, really, really wide range, okay? There's people that were just born. There are people that are in their 90s and even a couple people in their hundreds, well, maybe more than a couple, okay? We have people from a large range of gatherings, and so there's going to be people that are a long ways away from the average. The average might be, let's say, 45 is the average, or maybe 40 is the average, I'm not sure. There's a large range. And what that's telling us is that there is a huge grouping in this situation here. Okay, so there's a large grouping, there's a wide range. Standard deviation represents how big the range is. Do we have a really small range, everybody's really close to the same age, or do we have a really wide range and everybody is far away from there? Other things that standard deviation can tell us is how accurate, okay, or trustworthy the data is. If we're taking a look at data and we want it to be really consistent, but the standard deviation is really big, that means that it's going to be really far away. Okay, the data might not be trustworthy. If it's all really close to the average, the data could be really trustworthy. Okay, we could say how stable or erratic the results are. Are they really good or are they really all over the place? Okay, the bigger the deviation, the more untrustworthy, unpredictable, unstable, erratic, and unique something is. So the bigger something is, the less trustworthy we can consider it, or just a wider range that we have. The lower the deviation, the more consistent it is, the more predictable, the more stable it is, the more homogeneous. So homogeneous just means that it's all kind of the same. So if we have a really low standard deviation, that means that everybody is very close to the same. Or in this case here, we're going to have a low standard deviation for class A. It means that all their test results were very similar all the time. Okay? This class did very similar on all their test results. Okay? It doesn't mean that each student was very consistent. We could take a look at that data as well, but the amounts are very close. Okay? Being deviant is not a bad thing. Okay? It's not meant to be a bad thing. Just because something is unpredictable, untrustworthy, that's not meaning it's a bad thing. Okay? It just means that it's different from the group. Okay? It's just that something is different from the group. Things you want to be deviant in, if you're an athlete, okay, you want to be deviant. Okay? Deviant means that you want to be way above the average, okay? Because athletes you want to try to reach that really high level. If you're an artist or if you're an artist, and you're wanting to put on a show or musician, and you want to get to that really high level, you want to be way above normal, and that's okay to be deviant. Okay, lifespan, a lot of us want to live a long life. Okay, you got to be deviant, you got to be above average. Okay, and so that's what we're looking for. We want many of these things, we want to be above average, but we want to understand in data what is average and where can we match up in that. Now, how we